Hello, and welcome to Growing Up Fast, Kubernetes and Real-Time Analytic Applications. In this talk, I'll be discussing how to set up analytic pipelines to data warehouses using Kubernetes. My name is Robert Hodges, and I'm presenting this talk for KubeCon Data on Kubernetes Day 2022. I'd like to give a huge shout out to the DoK community for making this talk possible. Here are some quick introductions. Once again, my name is Robert Hodges, and I've been working on databases since 1983. I'm backed up by a bunch of database geeks from Altinity engineering who have collectively centuries of experience with databases and the applications that use them. We're particular specialists in analytic applications, which are applications designed to scan large amounts of data and give answers quickly. As a company, we're focused on analytic applications that are built on ClickHouse. We offer a cloud version of ClickHouse called Altinity.cloud. We're also authors of the open source Altinity Kubernetes operator for ClickHouse. As far as we know, it's the first Kubernetes operator developed for a data warehouse. Let me frame this talk by just discussing why we want real-time analytics and what purpose they serve. Let's take the example of an e-commerce site. That is to say, a website where we're actually selling goods and delivering them to customers. So the standard solution to answering common questions about this site is to build a data pipeline. And if we build it right, we can answer questions like, how can I boost the rate of return by posting special offers for products as users are walking through the site? Another important question that we need to be able to solve or to answer quickly is this transaction that I just processed fraudulent? To solve this, we're going to extract the e-commerce transactions so as people buy things, we're also going to extract the web server event logs. We're going to feed them into an event stream, which is going to push them over to a low latency data warehouse. From the data warehouse, we can then feed applications that do things like show operational dashboards so that people can see the current state of the business, and also forward information to fraud detection applications that can answer the question that we just posed a minute ago. Let's go ahead and build at least part of this pipeline in Kubernetes. So if we were going to process the e-commerce transactions and feed them into an operational dashboard, we might create a data pipeline with the following components. We have MySQL as the database, which is used to record e-commerce transactions. In other words, every time somebody puts something in their basket, every time they buy something, this is going to be committed as a transaction in MySQL. Those committed transactions are then extracted using a project called DBMS, which can do change data capture from the MySQL bin log. DBMS turns around, and as it extracts each transaction, it puts it into Red Panda, which is a very efficient, very fast, Kafka-compatible event stream. From Red Panda, the transactions flow to ClickHouse, which is an open source SQL data warehouse that has very low latency and can process very, very large amounts of information. And then the data in ClickHouse is used to populate operational dashboards that business analysts can look at to find out the current state of the business, basically up to within a few seconds of what's happening on the e-commerce website. Let's talk about how to actually build this pipeline. So typically when you're deploying it, you're going to deploy it one piece at a time. Let's start with a linchpin, which is the data warehouse. So what we'll do is go out to our Kubernetes cluster, create a namespace called ClickHouse, and then we'll run the following procedure. ClickHouse requires Zookeeper to control a cluster. So Zookeeper keeps track of information like what needs to be replicated between different server replicas. So we'll go ahead and run a script that sets that up, basically posts the deployment into Kubernetes. Once that's done, we're going to run another script which will install the ClickHouse operator. The ClickHouse operator defines what's called a custom resource definition, which can be used to define ClickHouse clusters. And it also installs a container which is able to process those custom resource definitions, or CRDs, once they appear in Kubernetes. And then finally, we'll create a CRD and we'll apply it to Kubernetes using kubectl. When that happens, the contents of the CRD will get passed to the operator and turn into, which will then implement it as a data warehouse in Kubernetes itself. Let's have a quick look at the custom resource definition in case you haven't seen one. So this is an example for ClickHouse, and as you can see here, it's a relatively simple file that defines things like the topology of the cluster, number of shards, number of replicas, where is Zookeeper located, and then, even though we can't see it in this slide, there's a couple of additional sections which define things like the pod definitions. In other words, what version of the server are we running, how much memory does it need, how much CPU does it need, and the configuration of storage. So this may seem complicated, but in fact, what happens is when the operator processes this, it will allocate 60 or 70 actual resources out in Kubernetes. So it's an enormous simplification of the process of setting up this database. Let's look at the full pipeline. So we see ClickHouse, which is set up, and then we notice that we go through a roughly similar set of steps for most of the other parts. You'll notice that they do differ, and that there's basically 3 different ways that pieces of the pipeline get set up. We can run a script, as we did for the Zookeeper deployment and the ClickHouse operator, or we could run a Helm chart, as we do for MySQL. It installs the MySQL operator. Finally, for anything that has an operator, we will then, once the operator is set up, we will create a custom resource definition to define that component, be it MySQL, Red Panda, or ClickHouse. That'll get processed, and then the component will get implemented in Kubernetes. One really important detail when you're building these pipelines is how to integrate the event stream, which can often be processing millions of events per second, how to get that data efficiently into your data warehouse. So up till now, common approaches for ClickHouse have been to build a custom application which will grab the data, do application-specific transformations, and stick it in ClickHouse. Another way is to actually have ClickHouse itself directly read from the Kafka-compatible event stream. It uses something called the ClickHouse Kafka engine, which basically can take a Kafka topic, make it look like a table, and then at intervals pull data from that topic, and then go ahead and populate an actual table inside ClickHouse. What are the other options? Well, when we want to have a lot of producers and consumers, one really powerful model that we can use is something called Kafka Connect. Basically, Kafka Connect is a protocol backed by a bunch of open source libraries that is implemented by Debezium, among others. And what it does is when Debezium grabs something out of the bin log, it turns it into a standard format that is defined by the Kafka Connect protocol. That format is then put into Red Panda, and it can be read out by another connector, which can then interpret the data types, for example, and the records, and then apply them into ClickHouse. So this is a really powerful technique that basically gives you interoperability with a wide range of producers and consumers. One of the things we've been working on at Altinity is to build an actual sync connector, as we call it, for ClickHouse, which can move things from the Kafka-compatible event stream into ClickHouse. So one final note, current practice, in the example that we began with, we created the entire pipeline inside Kubernetes. That's not really how people do this. If you actually go out to production systems, you'll find that there's a mix of managed services and Kubernetes. For instance, we could run MySQL in Amazon RDS, we could have Confluent controlling the Kafka-compatible event stream, and we could have ClickHouse itself running in the Altinity.cloud managed service. Anything else that doesn't fit in these 3 can just go into a Kubernetes cluster. So for example, Debezium, Grafana, any custom applications. Interestingly enough, Kubernetes itself is increasingly used as a managed application. So in this case, we use Amazon EKS, which runs the cluster for us, so we don't have to bother with administration. If you'd like more information, feel free to check out the Altinity Sync Connector for ClickHouse. That's a new project that we're developing. The GitHub URL is shown here. Just Google it. You'll find full documentation for what I've described here, as well as procedures for creating the entire pipeline with all its details inside Kubernetes. Thank you very much for listening to this talk. If you have further questions about analytic databases, data pipelines, and Kubernetes, feel free to contact altinity.com, or you can send email directly to me at roberthodges@altinity.com. Thank you for listening, and once again, thanks to the DoK community for making this talk possible.
So Robert, it looks like you're with us now. Yeah.
I am. Yes.
Yes!
Sorry about that. I had to
Yes!
turn off. I had to extricate myself from YouTube. Yeah.
It's all good. The thing is, folks, everybody knows Robert is at another awesome event, which is Percona Live. So that's why he
Percona
can't be with
Live,
us
yeah.
here in person. But anyway, so Robert, I'll just repeat the question. You know, like we talk a lot about operators, right? In the case of Altinity, your process of building a ClickHouse operator, what are some of the learnings that you got from that? And for other folks that might be out there that are thinking about building an operator as well, what advice might you give them?
Okay. I'll give you two learnings. One is it works. That's actually, and that's like, I did a previous talk with you, Bart, and I explained how I had this huge argument when I got my current job, and I didn't really think Kubernetes would work for data. Well, it turns out the operator model is just really awesome because you have these complex you have these complex topologies, as I showed in that example, and you can basically reduce them to a single file that then gets you a really well thought out deployment inside Kubernetes that can do things like upgrades, rescaling, and everything like that. So that's actually a really important lesson, because what it means is, like, if you have a database, you want to be using an operator to use it. And if you're planning to maintain databases yourselves, you want to write one just that does what you want. I think a concrete operator or lesson, which was actually a really important one for us, is that stateful sets are inadequate for managing things like data warehouses. And so the stateful set has a kind of a cool idea where, you're going to have persistent names. You're going to have, some number of replicas, which are going to be maintained for you automatically by Kubernetes. But we had a debate at the beginning. Should we just, have a stateful set for the entire cluster or even individual shards of these large clusters? And the answer is no. And the reason is that in Kubernetes and in data warehouses more particularly, you often need to do things like have nodes have very different configurations, operate at different versions, stuff like that. And stateful set just can't handle that. So that was kind of a core learning for us and put us on this path where we actually have a stateful set per node that allows us to make the name is predictable, have persistent storage attached to it. And so we don't lean on that part of the Kubernetes model. Instead, we just build on top of the persistent, the coherent naming and storage that we get from the persistent set or the stateful set.
All right, good stuff. And I mean, it's interesting that you're mentioning about, stateful sets, something that comes up a lot. And also when we're talking about, just data on Kubernetes in general, sometimes the issues of thinking, oh, how much do we have to shoehorn it on there? What do you expect to be happening, let's say in the next year from now? I know it's tough to, predictions and things like that, but 1 year from now, what do you think we'll be talking about when it comes to these, paradigms, patterns such as operators running data on Kubernetes?
I think that we're going to see a lot. I think one of the things that I'm seeing and that I think people are going to be talking about more is just how they can use Kubernetes to get to multi-cloud operation. And the thing about data that's really important is that people want the ability to run databases in places that they need them. And those can be everywhere from, like running up in a cloud to on-prem. And I think this portability story is still not fully played out. And this is something that as Kubernetes becomes more ubiquitous, people are going to start to think about, hey, I have a database and it's got an operator. I'd like to run it where I need to run it. And I hope that this is a conversation that we begin to have to stop thinking in terms of things being closed services, but instead having things like, like Postgres, like Redis, like Cassandra, like ClickHouse, that I can now move to that I can stand up, provision, and manage in the environment, specific environment that I need. Be that controlled by a vendor, done in their own VPC, or in a VPC that I control directly. So I think there's going to be an interesting conversation, and we're doing our best to start it, to get that going. That's something I hope to hear more about in the next year.
Good stuff. And like you said, and if you didn't check out the live stream that Robert did with us recently. Definitely need to get on that. When we're talking about these things of interoperability, when we're talking about things related to portability, these are key terms that you're going to be hearing more about, and key terms that we'll be talking about when we do our in-person meetup in San Francisco in July.
In July.
Yes, it's going to be good. Weather's going to be good.
Yeah.
Looking forward to that. Robert, thank you very much for your talk today. Enjoy the rest of Percona Live. Give our best to our friends from Percona who are out there and all the folks that are working on cool stuff related to data.
Cool. Thank you so much, Bart. Have a great time in Valencia.
Will do. Take care. Cheers.
Right.
Bye-bye.
Bye.